Okay, so this is the part 4 of the IBM barn find restoration. Since in the last episode I was able to revive the power supply, one what I want to perform before to go ahead in any other project here, I want to try if the motherboard has some life sign. So I already have switched on my electronic load and see if we can power it up. Okay, so it seems that we have an overload. Let me remove this one at a time. Yes. Oh, life signs. That of course is an error message because there are missing cards, so it's not reading the video card and the floppy drive controller, but hooray, it's live. It's alive. So next step is to check those tantalum capacitor which are prone to fail, and after that I can start with the insertion of the cards and see what's happening. And indeed, with the replacement of this tantalum capacitor, I have this result. Okay, so now the power supply can be powered on without the electronic load. I can plug both of the plugs that go on a motherboard. So same error codes, since I still have no boards on it. So let's try to mount some board. This controller board still power on, still error message. Video and parallel card in. No error message. That's promising. Time to plug monitor and keyboard and see if I have some behave. With the asynchronous card, okay, still happy. Let's see with monitor and keyboard. Okay, this is the result after few trials. I'm having this problem on the monitor, which the screen grid go high and high, so I have to turn off, then up again the light intensity on the monitor command. However, before that I have made several tries, and I always had, you see, it's coming back again. So the monitor need to be repaired because it looks like some problem. However, also the motherboard has some problem. It gave me always error, RAM error, and in fact I was able to trace 6 RAM chips that are bad. And what I have done, I have swapped it from the last bank of RAM. I have swapped it to the other 2. Likely they are socketed. And what I have done, I have changed the setting to 192 kilobytes instead of 256. So in this way I'm not having anymore the RAM error, and for sure I will need to replace those chips. But look at that. We are having a live computer. So monitor should be repaired because I have this weird, but the brain is back. So let's go ahead with the repair. Troubleshooting the monitor because I cannot adjust the brightness correctly. It turns out that the problem is simply the potentiometer. The wiper is not making contact on the resistive track and is only making short circuit when it go right to the end, to the counterclockwise end. So I'll try to open it and see if I can fix, since this is not easy to find right now potentiometer. So let's try to repair. It looks the internal of the potentiometer. So this is the wiper, and there is a double contact. There is an inner ring with two notch that make contact in the brass ring over here. Then there is the resistive track which is making contact with these two small fingers. I didn't find anything that was really bad, just a little bit of dusty, which I have already removed with these things here, but very little. What I believe that happened is that to remove the knob, this knob, it was so hard because it was rusty, the ring here. It was so hard that pulling out the knob, the inner ring notches has bent a little bit backwards, so was not able anymore to make a good contact here, hopefully. So let's try to reassemble and see if this fixed the problem. So the ohmmeter is connected and turning the potentiometer shaft. The potentiometer is potentiometering, back in business. So time to check if the monitor now is working correctly. Yes, and for sure the potentiometer has fixed the monitor issues. So perfect working monitor now. Well, this is another good result. Time to address the other problem that I have, and so let's go ahead. After an extensive cleaning and lubrication, this is the result. So it's quite silent. So the spindle is turning as it should. Time to address the stepper motor. Okay, it's just starting right now, waiting for some life sign, but it will remain in this condition for the rest of the day. So what's happening is that the head is going to track 0 and then go to the starting point trying to read. Okay, what I have discovered is that the floppy disk controller will access the bus, and when it is inserted an operative system diskette like DOS 3.2 or 3.3 like I have, it will goes directly onto the memory through the DMA controller, and this task it's performed after the microprocessor ready, and so it will give to the DMA controller the control of the bus in order to load the data coming from the disk onto the memory and fetching instructions from the disk and loading the operative system in the memory. It seems that there is something that it's missing during the process, so it starts to give the very first signal from the disk, recognizing that it is an operative system, getting the DMA controller to the DMA controller IC, but unfortunately it will freeze on that point, so the disk will spin continuously, waiting for the timing from the CPU. For sure the problem is in the motherboard, since I have swapped parts from a knowing working computer and have the same behavior. So nor the floppy disk controller, neither floppy disk drives are faulty. They are fully functional. So the problem lies in the motherboard. At this point, I think I need to study more in depth the way that it works and study a strategy how to connect the logic analyzer. Again, I am not a computer expert, so I need to think on it a bit. And since I have a lot of other projects that are laying around, I think that I will stop the video here and I will post the other videos that I am currently shooting. I have many other computer peripherals videos upcoming. So thank you very much for watching so far, and very soon you will see a very huge amount of computer videos. So stay tuned. Thank you very much again. Bye.